Okay. You probably need to be able to graph them, and you also need to be able to take a graph and turn it into a piecewise function.
Yep.
Yeah.
But I found graphing the piecewise function is definitely the hardest.
Okay, let's do one of those.
Okay.
Can you verbalize it?
Yes. So for what I am given is y equals, and then it has the swervy thing that holds three equations.
Okay.
Um,
It's the first equation.
2 if x is less than or equal to -3.
Second one?
4 if 0 is less than x if x is less than 2.
And the third one.
3 if x is greater than or equal to 2.
Okay. When you're doing piecewise functions, focus on this. Starting at the top right. And then go from left to right. In other words, we can see this goes from -3. Anything left of -3, if I put -3 on there like that, what's y equal to when I'm left of -3?
X is less than -3, so it has to be on the left-hand side of -3. Oh, over here, 2.
Exactly. In other words, that's the way you want to do it, is you want to start here. Whenever x is less than or equal to -3, y is 2. Well, y is 2 is a horizontal line, like that. Okay, now, did we miss an interval here? Was this x greater than 0 or -3?
That's how it's written.
Just like this?
Yes.
Looks like they skipped the interval from -3 to 0,
Oh, wait. It's
which is
0
unusual.
is less than x, which is less than 2.
So it's just like this.
Yeah, but it's not equal to 2.
Oh, it's just less than 2, like that. Okay, that's fine. So let's look at this interval. That interval goes from
The 2 is greater than the x on the last one.
it's like that, right?
Yes.
Greater than or equal?
Yes.
Okay. So this interval here is not represented, so there's not going to be any points there. Okay, the next interval goes from 0 to 2. So it's this interval right here. And what is y equal to in that interval?
4.
And is it closed or open dots
It is open,
on both ends?
and it ends at 2, at 0.
And then finally, there's a third interval, x is greater than or equal to 2. Whenever that occurs, y is equal to 3. Halfway in between 2 and 4. And that's a closed dot. So there's the graph. It's unusual in that usually piecewise functions don't have an empty interval like that. That's why I asked whether this might go to -3 instead of 0. But apparently not. This is fine. Okay. Do you have another one?
Yes, that one was very simple compared to the one I did in class today.
Most of these are simple if you approach them correctly. Just always start on the right-hand column. In other words, start with your domains. There's three different domains. There's x less than or equal to -3, there's this domain, and then there's this domain here. And each domain has a different y value. Let's do another one, and I think it'll be a little bit more clear.
All right. The first there's the y equals that sign. What is that called?
Talking about that?
Yeah.
Yeah, I'm not sure what that's called, but okay. What's the top function that it's equal to?
X plus 3 if x is less than or equal to 0.
And the second one?
2x if 0 is less than x, which is less than 2.
Yeah, the way I would verbalize that, it would be, instead of starting with the 0, say x greater than 0 and less than 2. And then is there a third one?
Yes. 3 if x is greater than or equal to 2.
Okay. Same thing. We're going to start with this domain. How do I draw the graph y equal x plus 3?
Go to x0, then you just go up 3.
Well, we'll start with the y-intercept, which is 3. And now what's slope? In other words, this is the equation of a line, but it's not a horizontal line or a vertical line. It's a line with slope. What's the slope?
Is it just up 1 over 1?
It's 1, the coefficient in front of x. In other words, y equal mx plus b. B is 3, and m is 1 for this part right here. So I know my slope is 1, which means I go down 1 or down 2 and over 2. It's a positive slope. So the slope goes like this. And should this be a closed dot or an open dot?
It should be a closed dot.
Okay. So that graphs that part. Now let's go to the interval 0 to 2. And what would the line 2x look like? What would its y-intercept be?
It would just be 2.
No, its y-intercept would be 0. Its slope would be 2. In other words, if I said graph y equal 2x, you would start at the y-intercept, which is 0, and right there, and then you would have a slope of 2, which means I got to go up 2 over 1. And should this be an open dot or a closed dot?
Open dot.
At both ends. In other words, open dot, excuse me, the second end is up here. In other words, I got to go up 4 and over 2. Let's see, that's 1, 2, 3, 4. Let's make it a little bit.
Why does it end up there?
Let's make it a little more precise. Because we're going to connect that with a line. In fact, that's not very good either. To make it end right there. And now we're going to connect that with a line.
And why does it end where it does?
It ends there because our domain is 0 to 2 for that function, for that part of this function. So we only are going to graph points between 0 and 2. In other words, this thing doesn't keep going in either direction. And finally, the third part is x greater than or equal to 2, which means everything in that direction there. And what kind of line should this be?
Wait, can you do that again?
Yeah, in other words, we've done this part here with those two segments.
Yeah.
The only part we still have to concern ourselves with is when x is greater than or equal to 2. So we're only going to address the rest of it in that direction. That's x greater than or equal to 2. Well, what's the function equal to whenever x is greater than or equal to 2?
3.
And how would I graph that?
You would go at the y-intercept would be 3.
Well,
So you just go across.
there's no y-intercept because we're only talking about x is greater than or equal to 2. So I don't have a y-intercept, but y equals 3 is a horizontal line. So I know that it's a horizontal line like that, but it only goes to the right. It doesn't go to the left. And it's a closed dot because when x is equal to 2, y is equal to 3. So that's that point right there. Now, it's going to be hard unless you take a picture to send me a graph of a piecewise function. So let's do this backwards. We're going to start with the function and figure out if we can figure out what the piecewise function looks like. Well, I just go in reverse. In other words, I can see that there are 3 different domains here. One domain is whenever x is less than 0, less than or equal to 0. In other words, that's going to take care of everything in that direction. And I can tell the function has a y-intercept of 3, and it has a slope of 1. I can measure that. So that must be x plus 3. Go to the second part of the domain and always work from the right down. The second part of the domain I can tell is greater than 0, less than 2 from my graph. And I can also tell that that has a y-intercept that would be 0. And if I count the rise and compare it to the run, I see that it has a slope of 2. So that must be 2x. And finally, the third domain that I'm concerned with is whenever x is greater than or equal to 2. And I can see that that's a horizontal line, and horizontal lines are y equals whatever number it's on. It would have a y-intercept of 3 if that were in its domain, but the y-axis is not in its domain, so that's never going to go all the way over. In other words, that's the way to go either way. If they give you the function and you have to graph it, or if they give you the graph and you have to come up with the function. Do you have one that has a graph that you have to come up with the function?
Yes.
How quickly can you take a picture of it and send it to my email address?
Pretty quickly.
Yeah, shouldn't
I
take.
attempted to do it in class and I did it with the teacher, but I'm still super lost.
Okay. Well, the best way to do it is to go ahead and send me a picture of the graph, and then we'll go through and figure out what the function must be.
What is your email?
It is davidcowan1949 @ I'll write it.
That's right, I got it.
Okay, and Cowan is Cowan, and it's 1949 @gmail. Are you taking your ACT this Saturday?
No, I'm doing it in October.
Okay. I just finished a 2-hour session with a girl who's taking it this Saturday.
Oh. Is she nervous?
Oh, she's a little overwhelmed, I think. It's hard to cram a whole year of algebra and a whole year of geometry into just, a few hours. And we've worked on it for 4 hours now. But, so I don't know. It's tough for me to tell whether it'll help her that much. Best way to really study for the ACT is slow and steady. Kind of like you're doing. I think the material is easier to learn and remember if you do it that way.
Yeah.
Let's see, did you send it yet?
Yes, I did.
Oh yeah, there it is. It just came in. All right. So if we're going to attempt to figure out what this is, first of all, they're all straight lines. These two are going to be in the form y = mx plus b, and this is going to be y = 2, or the three functions. But again, let's start on the domain part.
Is X.
And start on the negative infinity side of the domain. So what would the top right thing be? In other words, we've got the y over here, and we're going to begin not with the function, but with the domain.
For the bottom one. Okay.
No, for the top one. In other words, they usually go left to right. So the very top domain is going to be everything from negative infinity to what point?
2.
-2, right? That's -2 on the x-axis.
Okay.
So that is less than 2, not less than or equal, because it's an open circle.
And it wouldn't be -2?
Excuse me, sorry. Yeah.
Oh, okay.
Didn't mean to confuse. No, that's very important. Okay, so that's -2. Let's do all of the domains before we figure out each function. What's the next domain going to be?
Of the next equation,
Well, not the equation, the domain. In other words, the right part of this thing is the domain.
Would it be
What's this domain, this middle part right here?
0?
Well, what does it go to? On the x-axis only.
Goes
From what
from
to
negative
what?
2 to 2.
Okay, then that's negative 2, and that's 2. Is this greater than or equal, or just greater than?
2 is greater than for x. X is greater than negative 2.
It's greater than or equal, because it's a closed dot. See that?
Yes.
Okay, and is it less than or equal to the next number?
Just less than 2.
Okay, so that's the domain on the middle segment. What's the domain on the final segment?
It is 2.
Define it in terms of x.
X is x is greater than or equal to 2.
There you go. So we've got all three domains. Now what we have to figure out is what the equation of this line is. Well, what's the slope? This line doesn't go all the way to the y-axis. So it's a little harder to do because there's no y-intercept. There is, if we wanted to extend that all the way, we could see that it looks like it would go through 2. What's the slope on this line?
It's up 1 over 1. It's just 1.
Okay.
Right.
So the formula is going to be y equals x plus whatever its y-intercept would be, right? Now, it's a little dangerous to just extend that line and hope that it goes through 2. So there's a more precise way of figuring it out. I can see that the value for y is 0 when x is minus 2. Therefore, that would have to be 2. And that's your top, or that is the function of the left segment. And how did I get that? Well, I can see that when x is minus 2, y is 0. Well, when I plug in x of minus 2, y is 0. So this function makes sense. Fits this line we're looking at there. And you can do it a couple of ways. You can actually extend it to see where it would cross the y-intercept, and we can see that it would cross it too. Or we can solve that point right there, which we did. In other words, we can tell that when x is minus 2, y is 0, therefore this has to be the linear equation. Okay, now let's go to the middle one. It's a straight line also, so it's going to be described as y equal mx plus b. What's b? On the middle line segment.
0.
Okay, what's the slope?
Slope is up 1 over 2, so 1/2.
Okay, so what's the equation of a line that has a slope of 1/2 and a y-intercept of 0?
Y equals 1/2 x plus 0.
Or just y equal 1/2 x. And finally, whenever the domain is to the right of 2 or equal to 2, what is y equal to?
Zero.
What is y equal to right here?
Y is equal to 2.
All the way. No matter how far I take that line to the right, y is still 2. And there's your three equations. Okay? Piecewise functions are actually quite easy. You just have to follow the right order of things. You don't want to jump around. You want to start, if you're given the function and you have to graph it, start there. If you're given the graph and you have to come up with the function, start here. In other words, start your domain at basically negative infinity to whatever this first number is. Are there more on this page, or is this the only one on this page? It looks like that's it.
That's kind of it. I want to focus on arithmetic sequences now.
Okay. So general formula for an arithmetic sequence.
AN equals A1 plus D in parentheses N minus 1. And we get to use that on the test along with the recursive formula, which is that funny sign, and A1 equals the start, and AN equals AN minus 1 plus D. And that's only used when you're trying to find all of the numbers in the sequence.
Right. The standard is this one here. The difference between the recursive is always, A sub n is always a function of A sub n minus 1, whether it's arithmetic or geometric. Have you done geometric also? Or just arithmetic so far?
Just arithmetic so far.
Okay. So you can tell that anything that's an arithmetic sequence, if I had something like 2, 5, 8, 11, that any term is going to be the last term plus the difference, right? In other words, 11 is going to be 8 plus 3. 8 is going to be 5 plus 3. So if I wanted to define this recursively for arithmetic sequences, it's real easy. The nth term is always the term before it plus the common difference. Now, what specific problem do you have?
Write the rule for the nth term in the sequence, then find a to the 25th.
Okay.
So the first sequence is 50, 45, 40, and 35.
So a sub 1 is, what's a sub 1?
The first term in the sequence, and that's 50.
And what's D?
D is the common difference.
Which is?
Minus 15.
It's minus 5, I believe, isn't it? You said 50, 45, 40, 35?
Yeah, I'm sorry.
Okay. So we have everything we need. So a sub n is equal to 50 plus a minus 5 times n minus 1. And we could simplify that a little bit if we wanted to. In other words, if I want to simplify that, it would be 50 minus 5n plus 5, or 55 minus 5n. So there is a sub n. And what did they want? The 25th term?
Yes.
Just substitute 25. So a sub 25 is equal to 55 minus 5 times 25, or 55 minus 125, or minus 70.
Can we do it with the original equation?
I'm sorry, what?
Can we do it with the original equation?
Instead of the simplified one?
Yes.
Okay.
That's all we've gone over so far.
It is actually easier to I didn't need to simplify it. I wasn't going to, but I figured I might as well do that anyway. But you don't have to. In other words, if I'm just going to plug in 25 for a sub n, a sub 25 is going to be 50 plus a negative 5 times 25 minus 1, which is 24. Or 50 minus 120, or minus 70. So it's just as easy if you're trying to calculate some a sub n to use the original one. But if they said give the formula for it, you want to simplify that. In other words, that's not simplified. So if it's like a two-part question, in other words, give what a sub n is, and then the second part is what is a sub 25, well, you can certainly get the a sub 25 from this, but you wouldn't want to give that as a sub n because it's not simplified.
And then the answer would be 2.8?
No, the answer would be minus 70 if you want the 25th term.
A of 25 equals negative 70, and we just leave it.
Right. And the way you verbalize these, this is a sub 25. In other words, because it's a subscript, you usually use sub to denote that. It's not a to the n power, and it's not a times n. It's not a of n. It's a sub n.
Okay.
Okay.
There's another problem just like it that I would like to try by myself, but I still would like
Go
a
ahead
little
and
bit
give me the sequence, and then I'll just have you go through it.
Okay. So it's negative 3, 1, 5, 9, and 13.
13. Okay. So starting with the general.
A is negative 3, and D is the common difference, which is a plus 4.
So if I want to put in minus 3 plus 4 times n minus 1, there's the formula right there. Still not simplified, but we don't need to apparently. And they want what? Which term?
The 25th term.
Again, okay, so a sub 25, just a question of substituting 25 for n.
Is 26, minus 3, 93. So 93 is the 25th term.
And we could prove it by just keep going here. You know, keep adding 4 20 more times, and we'll be at 93. But the reason we have these formulas is so we don't have to do it the long way. In other words, this allows you to figure out what the 260th term would be also.
All right, then I'm feeling super good about arithmetic sequencing.
Okay, good. They can give you some harder problems than you've given me. In other words, they might give you a problem that says the third term is 5 and the fifth term is 13. Now how do you do it? Because they don't give you a sub 1. But I don't want to necessarily give you that tough of a problem if you aren't.
They just give me the next problem is a of 13 equals 20. The common difference is negative 2. What is the rule for the nth term?
Good. D is what again?
D is negative 2.
So if the 13th term is 20, I can say right? And I can replace this with 20. Now we can figure out a sub 1.
Wait, why can we replace?
Because they told us the 13th term was 20.
I want to go through how I make the equation. Okay, so 20. Okay.
Right. Start with the general. Always start with the general.
AN equals A1 plus D times N minus 1.
Okay, and they've given us a sub 13.
A sub 13.
They told us that that's 20, so I'm going to replace that with 20. And they've also told us that n is 13. So I'm going to replace n with 13. And they've given us d. So the only thing they have not given us is a sub 1, and I can now figure out what a sub 1 is by solving this equation. In other words, a sub 1 is equal to 44. Now I have my general a sub n equals 44 plus a minus 2 times n minus 1. And again, if this is what they're looking for the answer, is that what the question was? Or,
yes.
Yeah, we wouldn't want to give that. We would want to simplify that. In other words, I wouldn't have to simplify that if the question was, what is a sub 50? It would be easy enough to just substitute in. But if I'm giving the general format for this particular arithmetic sequence, I want to simplify it. So I got 44 minus 2n plus 2, which is 46 minus 2n. And that's what a sub n is. Okay. And then once you have it defined, a sub n, now you could tell them what any term was very easily.
All right.
So they don't always give you a sub 1. Or they don't always give you the common difference. In other words, if you want to give a tough problem, say that a sub 13 is 20 and a sub 15 is 16. And those are the only two pieces of information they would give you. Well, that's going to give me two equations and two unknowns, and once I get two equations and two unknowns, I can solve for both of the unknowns. Notice let's do this one, because this is as tough as you're going to see, is this problem right here. So if I give you a sub 13 and I give you a sub 15, let's not calculate the common difference yet, even though it would be easy enough to do. Let's make it a little harder. Let's make it a sub 21 equals 2. Hold on a moment. Let me make it equal to 4. Okay? So those are the two pieces of information I give you. And if I want to come up with the equation of this arithmetic sequence, this is what I would do. I would set this first one, 20 equals a sub 1, which I don't know, plus d, which I don't know, times 13 minus 1, which is 12. There's one equation and two unknowns. And then write a similar equation. If a sub 21 equals 4, same d, but now it's 21 minus 1, or 20. So now I have those two equations. And to solve them, what's the best way to solve those two equations? Remember, we need to solve, in order for us to write the final equation, we need an a sub 1 and we need a d. So I need to solve these two equations to get a sub 1 and d. It's the best way to solve those two equations.
Would you do
Elimination or substitution? Those are your two techniques. Well, when it's in this format, this is standard format, where both my variables are on one side and only numbers are on the other. This solves very easily by elimination. So all I got to do is subtract one equation from the other. What do I get when I subtract the bottom equation from the top?
you get
It's 20 minus 4.
16 equals, then the A's and D's cancel out.
Not the D's. I've got 12D here and I got 20D there.
Oh, those are, okay.
Yeah, what's 12D minus 20D?
12 minus 20 is negative 8.
So that's negative 8D. Yeah, don't be fooled by the number being to the right of D. That's still the coefficient of D. And now I've solved for D. D equals minus 2. Well, once you solve for D, once you solve for one of the variables, I can go up into this variable and figure out what a sub 1 is. A sub 1 would have to be 44. In other words, if I substitute minus 2 for D and solve for a sub 1, I get a sub 1 equals 44. And those are the only two things I need to write the general equation for that sequence, is a sub 1 and D.
I like substitution.
What's that?
I like systems of equations.
Yeah, usually between the two techniques, elimination or substitution, substitution works really well if one of the variables is fully defined. In other words, if I change this first equation around so that it's a sub 1 equals 20 minus 12D, same thing, I've just moved the 12D to the other side. And then I have a second equation that says 4 equals a sub 1 plus 20D. Well, now this system of equations is actually more easily solved by substitution because a sub 1 is fully defined. It's 20 minus 12D, so wherever I find a sub 1, I'm going to substitute that. So I'll have 4 equals 20 minus 12D plus 20D, and now I can solve for D. So either technique works. Personally, I use substitution only when one of the variables is fully defined, and if I can use elimination, I usually do. And you can see why, because elimination is pretty easy in this situation. In other words, I don't have to do much to eliminate a variable. All I got to do is subtract the two equations. Might be a little different if I had a 2 in front of that. Now I got to manipulate one of the equations before I can subtract them and eliminate a variable. But this one comes set up perfectly for elimination. In other words, whenever you can merely add or subtract the two equations and one of the variables goes away, that's where you want to use elimination. Because it's quicker. It was much quicker to use elimination to come up with 16 equals minus 8D. That's instant almost. Mm-hmm. As opposed to substitution, which required more algebra.
Cool. Can we do systems of equations with 3 variables?
Yeah, absolutely. Give me the 3.
There is x plus 4y minus 6z equals -1. Then the next equation is 2x minus y plus 2z equals -7. And then negative x equals negative x plus 2y minus 4z equals 5.
Okay. Our goal is to pick a variable, try to eliminate it, then use 2 different equations and eliminate the same variable. So I'm going to end up with equation 4 and 5. And in fact, I like to number these because you end up with equations all over your page. And if you don't number them, it's easy to get lost. So is there a variable we can eliminate without doing any manipulation at all?
X on 1 and 3.
If I add 1 to 3, okay? So that's going to give us equation 4. And what is that equation going to be?
It would be 6y a negative plus negative equals positive 6, 7, 8, 9, 10. So plus 10 equals...
Hold on. I'm adding these 2 equations. When I add minus 6 to minus 4, what do I get? What's minus 6 plus minus 4?
It's -2.
Negative 10.
Why is it -10? I thought negative plus negative equals positive.
No, not when you're adding. When you're multiplying, yes, but not when you're adding. When you're adding, negative plus a negative is negative. So it's minus 10z. Add the 2 numbers, you get 4. Okay? And I wrote it off to the side for a reason. Because now we need an equation 5. And my equation 5, I want to eliminate x also. I don't want to eliminate a different variable. I want to eliminate x because if I eliminate x, I'm going to have an equation that's just y and z, and then I'm going to have 2 equations, 2 variables, and I can solve it normally. So how do I eliminate x? And I can combine anything but 1 and 3. I've already used 1 and 3. But I could use 1 and 2, or I could use 2 and 3. Which ones should I use?
2 and 4.
2 and 3. In other words, you want to use 2 out of the original 3 equations.
Okay.
Okay? This is equation 4, which is valid, but we're going to have an equation 5, but before we can get equation 5, I need to manipulate one of these first 3 equations because I'm trying to get x to go away. So what if we play with 2 and 3? Those 2 right there.
We can multiply the bottom one times 2.
Okay, let's do that. I'm going to label that same equation 3. And now I'm going to combine this 2 with this 3 to produce equation 5. What is equation 5 going to be?
Wait, which we're combining 2 and 3.
2 and the new 3.
All right, then it's going to be 2x minus y plus 2z equals -7. So then it would just be 3y. Oh, got it. And then minus 6z.
You got it?
Thought it was a 2. And then equals 3.
All right. So now we've taken our 3 equations and 3 unknowns and turned it into 2 equations and 2 unknowns.
Right?
Now we're going to solve this system of 2 equations and 2 unknowns in the normal way. Let's go ahead and do that. How can I eliminate a variable here?
We could multiply the bottom one that we just made by 2. Get rid of the y.
Now what?
Now we can subtract them.
Okay. What do you get?
Negative plus negative does take a positive here, and it'd be 2. 2z equals -2.
So z equals -1.
Then we plug that back in.
Plug it back into either equation 4 or 5. Not the first 3, because you won't be able to solve for anything. But if I plug it into either 4 or 5, I can then solve for y. Once I have a number for y, I'll go back to one of these first 3 equations, the simplest one, and plug in my value for z, my value for y, and then I'll be able to calculate x.
Got it. I learned this. I just needed a quick refresher.
Yeah, and the whole key is producing equations 4 and 5 that are both missing the same variable. In other words, you don't want to eliminate x for equation 4 and then eliminate y for equation 5. That won't help you. In other words, if my equation 5 had an x and a z, I wouldn't be able to solve it. Then I would have 3 variables and 2 equations. So I got to make sure I have the same 2 variables in equations 4 and 5. And the only way I can do that is to make sure I eliminate the same variable when I eliminate to produce 4 and 5. Okay.
All right.
Okay.
I think we can stop here.
Okay. You sure? There's another 5 minutes if you have any last questions.
Oh, yes. How does my mom pay you? Are you going to send her a PayPal thing?
Yeah, I can certainly send her an invoice. Let me make sure I have her address. Let's see. Is this email hers or yours?
That one's mine.
That's yours? Okay. Why don't you give me hers? What's her email address? I might have it somewhere, but just in case I don't.
DCSHOEM@mac.com.
Mac? M-A-C?
Yep.
Okay. I'll send her an invoice and she can pay with PayPal. The easiest way to pay with PayPal is to go to my digital math tutor site. If you go to www.digitalmathtutor.com, digital math tutor, you have to almost put in nothing in order to pay. You just have to put in the number.
Cool.
And yeah, you hit the buy now button and it lets you enter the amount due, and then it asks you for your account number for PayPal.
Cool. Got it. I wrote it down so I can tell my mom.
Okay. And Digital Math Tutor is basically has all the same features as Algebra to Calculus Tutor does. In other words, the same scheduling. Did you go to Algebra to Calculus to schedule tonight's session?
Yeah, I think so.
You can get to that same page by going to Digital Math Tutor. In other words,
Okay.
Digital Math Tutor lets you schedule sessions and pay, and the paying part's a little easier on Digital Math Tutor. It's built in, whereas on Algebra to Calculus, you actually would have to send a PayPal payment to David Cowan 1949 at Gmail. So Digital Math Tutor's probably the one you want to use regularly, I would think. Okay?
All right. Well, have a good night. Thank you very much.
Okay, Emily, and I will talk to you tomorrow.
Talk to you tomorrow.
I'll be ready to work on ACT.
All right.
Okay, bye-bye.
Bye-bye.